This is a mock scatter plot project. I researched student population trends in the Plymouth School District. This kind of information is necessary for the Plymouth Public Schools to collect every year. It's necessary for them to know how many students they have enrolled in each grade so that they can plan accordingly for student schedules. This data would also be important to the town of Plymouth and the town hall when they start allocating taxpayer money to support the school buildings in the district. It may also be important to homeowners, either looking to leave the Plymouth area or looking to move to the Plymouth area. Maybe a decrease in student population might also mean a decrease in funding, or an increase in student population may mean an increase in funding, and maybe a young family that's just starting out might be interested in what the trends are in the area for the district and what 10, 20 years down the road might look like based on those current trends. I got my data off of the school committee website from the town of Plymouth. There is a link directly to the school committee website, and this chart, this report is part of the district report that they do, I believe, every year. If you look, all of my data is from fiscal year 2003 to fiscal year 2012. That fiscal year is actually the year that they're financing those student numbers. The actual year is 2002, and then the actual total in 2002 is that 9,236. That's the total number of students that were enrolled in the district. So when I create my scatter plot, I'm going to be using the years 2002 to 2011. I'm going to ignore the fiscal year portion. This isn't a financial discussion. This is a discussion based on just the total enrollment for the district. If I wanted to, I could have looked individually at a grade level. As you can see, this is all broken down from kindergarten to 12th grade, but I'm just interested in doing a general population total. The first step in my process is to create a scatter plot where I can graph this data and look at the trends. So what I'm going to do is label my graph. My graph is a graph of the student enrollment trends from 2002 to 2011. I'm going to use the x-axis for years, and the y-axis I'll be using for student population totals. And then I'm going to label my x-axis and my y-axis so that I can cover the scope of my data. If you look, my x-axis goes from 2002 to 2014. The data that I have goes from 2002 to 2011, so I know that I'm going to be able to graph everything. Also, the data that I have begins around 8,000 for student population total, so that's where I began. It goes all the way up to 9,236, so I made sure that I went a little bit past that in both directions so that I could see what the trend of the data was and make some valid predictions. Now that I have graphed all of my data values, it's pretty evident that there is a steady decrease in the number of students attending Plymouth schools from 2002 all the way to 2011. The enrollment totals have decreased. My next step is to draw the trend line of my data set. As I said, it looks like there is a steady decrease. It looks to be a linear relationship, so I am going to draw a line of best fit, a line that I think best represents the average of my data set. I like where this trend line is because if you notice, there are an equal number of data values below the trend line as there are above the trend line. So I think that I drew a pretty good line that best represents the average. When drawing the trend line, I do want to use my data values to make sure that I'm best representing the average, but once I've drawn that and I'm ready to write my prediction equation, I want to kind of ignore that those data values were ever there in the first place. So what I've done is kind of deleted them from your memory so that we can look specifically at this trend line and write an equation of that line, not of the individual data values. So what I've done is I've looked for areas where the grid seems to intersect at nice, neat points. So I picked a point right there, and also I picked a point right there. Those look to me like nice, neat points that I can use to calculate slope and write a linear equation. Once I've chosen those nice, neat points, what I want to do is label them and pull that data from the graph, and then I can essentially ignore the trend line and work with the point slope formula and write a linear equation. There are two formulas that I need to take into account when I am writing any linear equation. The first is the formula for slope. Slope is the change in y over the change in x. The second is the point slope formula. What I'm going to need to do is take those 2 points that I chose off my trend line, calculate slope, and then plug that into the point slope formula in order to write a linear equation. Based on the image of my trend line from the previous slide, I think we can all conclude that the slope should be negative. And when I do calculate that out, when I do the change in y over the change in x, I do end up getting negative 700 over 5, and I get negative 140 for a slope. So we're lucking out here. We have a nice, neat, even number. And then what I'm going to do is choose one of my data values. I think I'm going to choose this one because the numbers look neater. And I'm going to choose that negative 140, and I'm going to use that to plug into the point slope formula. Once I've plugged into the point slope formula, I then am going to have to take that negative 140 and distribute it into my parentheses to eliminate those parentheses, and then my next step will be to get it in y equals mx plus b form by taking this negative 8100 and moving it over to the right-hand side. When I do distribute over that negative 140 into those parentheses, the negative times a negative does cancel out, and I do end up with a positive number over here. And then my final step to write my prediction equation is going to be to take this negative 8100 and add that to the 281,400. My final answer is then y equals negative 140x plus 289,500. This is my prediction equation. I can use this to predict any future values. I could also use it to check the validity of my trend line and see if it can get within the ballpark of any of the existing data values that we have. I'm now going to take the prediction equation that I wrote from my trend line, and I'm going to use that to predict the future student population in 2015. This means that X is 2015. If you think back to how we drew our graph originally, we put years on the X-axis. So if I'm predicting the student population total in 2015, I'm looking for what Y value should I have when X is 2015. So what I'm going to do is take my prediction equation, and where I see X, I'm going to replace it with 2015, use the order of operations, multiply by that negative 140, add 289,500 to see what that Y value is. Using the order of operations, I end up getting a negative value right here because we're multiplying by that negative 140. And when I take that negative value and I then add that to 289,500, I end up getting a projected student population of 7,400. What this means is that my prediction equation has projected that student population to be 7,400 in the year 2015. That doesn't mean that it's going to be the actual student population. What it means is that if we continue to go down this path with these current trends in student population, if we continue to decrease at this rate, by the time 2015 hits, we will be at 7,400 or somewhere within that ballpark. I should be able to tell if my answer makes sense just by looking at the trend line. If we look at where we're starting at about 9,236, and where my data ends is around 8,100. Now, if I were to continue this trend down to 2015, which would be about here, and continue along that same slope, it looks as though I would be well below 8,000. It looks as though I should be in the 7,000 range. Now, because I didn't draw enough of those data values below, it's hard to tell exactly, but it looks as though, based on the trend line, that my answer is fairly valid. It's important to keep in mind that that estimate is based on the trends in the data staying the same over time, past 2011 into 2015. There are certainly outside factors that could potentially interrupt those trends and maybe cause the student population to increase instead of the current trend, or maybe cause it to drastically decrease. For instance, if a new charter school were to come into the Plymouth area that was very attractive to parents in the district, maybe we would have a decrease in the number of kids attending middle school or attending high school, which is something that happened recently. Likewise, there could be a new private school that was introduced into the area, or there could just be an increased interest in sending your kids to private school, maybe based on MCAS scores or just based on trends in your neighborhood. New construction and new families moving into the Plymouth area could also cause a drastic increase in the number of students attending public school. That happened back in the 90s when the Ponds of Plymouth sprouted up in the South Plymouth area. We saw a huge increase in the number of kids living in that region, and as a result, we had to build a South Elementary School to accommodate that increase in student population. Another unfortunate factor is possibly a bad economy. If the economy is bad in the area, it could cause families to uproot themselves and move closer to an urban area where a recession is not likely to affect the job market as drastically. So a bad economy could cause lots of families to just pack up and leave and no longer enroll their kids in Plymouth schools. In fact, any sort of real estate trend, empty nesters, leaving, migrating toward the south, toward warmer weather because they have a big empty house, that'll cause new families to move into the area. New families moving into the area means new kids enrolled in the local school system. The hardest thing about this project was definitely learning how to project my voice into a computer and trying not to sound like a robot and trying to talk at the appropriate volume. So hopefully this isn't as robotic as I think it is. At your seats, you should now be coming up with your own storyboard layout of your presentation so that you're ready to put this together on iPads tomorrow in class. Good luck.